Okay, now I will show you the complete process. Okay, meaning that we pick up the circle product, okay, from here and then put here. Alright, so I will put the demo. Okay, so assuming that the circle product already taken and then place here. Okay, the next process is actually how we want to perform looping, meaning that the process continuously to run. But I do want, okay, in your task, what you have to do is actually to delay, let's say 3 seconds in order for the next process to continue. Meaning that once this cylinder, okay, this circle product have been placed here, right? And then wait for 3 seconds and then the new product coming and also then place here again, continuously looping, okay, right? Every new cycle, it must be delayed 3 seconds. So how to do it? Alright. Okay, so since I asked you to continue the step sequence diagram, so the please continue part will be filled by you. So assuming for the next step, so the second last step, what you can see is actually I do put when Z-axis retract sensor here, okay, detected. Alright, what I have to do is actually at moment I have to trigger a timer. So at that moment the timer is triggered to delay the process, and then that timer will be used to trigger the last step. Alright, and then the last step will be used to trigger again the first step. Okay, so I don't put the number of steps because this one depend on your programming. Okay, but if you notify, there is actually a counter there, but later on I will explain. So now we move on how to make the looping process and also include a timer. So now continue to PLC program. Okay, so let's continue on PLC program. Okay, so as mentioned there, alright, step you have to fill by yourself. M1.3 Z retract sensor I already draw, so I have this one. So that will be the step sequence diagram for my last step. Okay, and do remember at this moment this, okay, memory must trigger a timer. So now I will teach you how to include a timer in your PLC program. Okay, so to include a timer in PLC program, what you can do is actually here find the timer. So this is the timer. Okay, expand it. Okay, use on delay timer. Okay, and then bring to here. Alright. Okay, so now you can declare this timer if you highlight. Okay, it is mentioned, okay, specific number of timer. Let's say you are using T32, then it will be counting interval 1 millisecond, or T96, T3063, right? Okay, 33 until 36, 97 to 100, 10 millisecond interval. 100 millisecond will be 37 to T63, and also 101 to 255. Alright, so now what you can have to do is actually to declare the timer. So my choice, I will choose the timer, let's say T37. Okay, T37. Alright, automatically this will be my interval. Okay, 100 millisecond. Okay, so now how to make 3 second delay? Okay, we have to declare here 30. Why 30? 30 multiplied by 100 millisecond, we get 3000 millisecond. 3000 millisecond equals to 3 second. Okay, now the memory to trigger T37 as do in the step sequence diagram, you can see M1.3 is used to trigger. Alright, timer, sorry, that one should be 37, okay, not 63. Alright, so what you have to do is actually here, alright, now we are moving to the program, BitLogic. So moving to here and then bring, so here must be M1.3. Okay, so that is actually how you declare the timer. Okay, so once completed, then okay, if you see the following step sequence diagram, alright, I will make change a little bit on this one because we are wrongly choose the timer. So this one should be 37. Here will be 3 seconds. Okay, so 37, 3 seconds, and here must be T37. Okay, right. So now completed. Alright, so what you can see now, 37. Okay, for the last step, it will be input the T37 for input of step the last one, and the memory will be M1.4. So 1.4, if you can see here, I already draw, so I can change here to 37. Okay, alright, T37. Okay, just checking. Right, 37, 100 milliseconds, so 30. Alright, okay, correct. So now to do looping program, as I guide you in the class, what we can do is actually the last step must set the first step. So that's why step M1.4 used to set M0.1, and the first step, okay, here must reset the last step. Our last step is M1.4, so that's why here reset M1.4. So in our PLC program, okay, we draw the last step program first. Okay, so this will be 1.3 T37 M1.4, the last memory. All right, and then 0.1 and 10.0. Okay, don't forget you have, okay, we already reset by using M0.1 as mentioned in this step sequence diagram. So reset M1.4 by M0.1, M0.1, reset M0.4. So one thing is actually on set again M0.1. So where is M0.1? Okay, here. What you can see, M0.1, okay, set by M1.4. So we already completed the looping program and also delay. Okay, another one is actually, all right, the counter. All right, if you can see that M1.3 is used, okay, to trigger the counter. So how to declare counter in our program? Okay, we move to here. All right, okay. So where is your counter? So it will be here. Okay, opening. So counter up. All right, bring to here. Remember, counter require 2 inputs, so I declare the counter here. First one is C1. Alright, so it will be the same memory as triggering the timer. So this one I will just paste. Okay, so the counting value I will set 3. Okay, so for reset, what we can do, we can put M10.0 because it is used as our emergency stop. So I will put here. So this one will be M 10.0, or you can use it as our initial condition M0.0, but this one I just put M10.0. but if you want to put both, most welcome. So what you can do, insert. Alright, so this one. Okay, so I will drag this one. Try to make parallel, right? Okay. Alright, let me drag this one first. Okay. Oh, so this one, okay, I cannot make it in parallel. Okay, never mind. Just leave it as this one first. Later on, I will shoot. Later on, I will troubleshoot why I cannot make it in parallel. Okay, once completed. So then, all right. Again, what I will do is actually to stop the program. When the counter equals to 3, I will stop the program. So how to do it is actually I already done here. So where I do put the counter value to trigger M10.0. So meaning that when counter C1, okay, activated, it will reset or triggering the M10.0, where it directly reset every memory as we apply, because we every memory we do put 10.0, 10.0, then all activator also will be reset. Okay, 10.0, 10.0, and so on. Okay, once completed, right? So again, we have to download Alright, download. And then, okay. Okay, so don't forget also the program status. Alright. Alright. Okay, so alright, so everything ready, so we can test the program.